Hi, welcome to this video series on how to write and publish Ethereum tokens in Solidity. My name is Ayuba John Kwamawazu, and I'm a software developer from Nigeria. Been in the software and blockchain space for 4+ years now. And in today's video series, I'm going to show you how to create, or rather, how to write and publish Ethereum tokens in Solidity. So first and first, what are crypto tokens? And then what are the types of tokens that we have? And then what are the use cases of crypto tokens? To simply start, we start with what are crypto tokens. Now, a crypto token is a virtual currency token or a denomination of a cryptocurrency. You have to understand that a token and a cryptocurrency are being used interchangeably sometimes, but there is a slight difference in their meaning. While cryptocurrencies are designed basically for exchange of value, crypto tokens are a bit further than that. For example, crypto token can represent a tradable asset or utility. Crypto tokens can also represent an investor's stake in a company, or they can serve an economic purpose, just like legal tender. So cryptocurrency are designed basically to be a legal tender on the blockchain, while crypto token, like I said, is a bit further than that. Now, in this video series, we are going to see how we are going to create a crypto token that represents an ownership, represents a tradable asset, and can also represent a utility. So we're going to look at all that in this video, and I'm going to teach you how we can create that on the blockchain, especially the Ethereum blockchain, and then how we can deploy that and use it and share it with our friends. So tokens that reside on blockchains include as crypto tokens that reside on blockchain includes reward tokens, currency tokens, utility tokens, security tokens, and asset tokens. Now, reward tokens are a special kind of tokens that you create to enable your users to have a certain form of reward when they perform activities on your platform. For example, you could give points to users that shop on your platform. For example, let's say we have an e-commerce platform, and then you want to reward your users with certain points each time they perform a certain kind of transaction. So we can create crypto tokens on the blockchain to do that, where we can reward our users based on how they use our platform. And secondly, we can also create currency tokens. There are also crypto tokens that can be created on the blockchain for the exchange of value, for the store and exchange of value. Currency tokens are more like cryptocurrency, actually, like blockchain, like Bitcoin, Ethereum, and the rest. These are cryptocurrencies or currency tokens that can be that can serve as legal tender. They can be exchanged for goods and services. Then we also have utility tokens that can be created to they can be created to buy utilities, like to buy electricity units, to buy our gas units, and any form of units that we can think of. So we can create utility tokens to do that, where you can use that kind of tokens to purchase some certain kind of utility services that are out there. They also have security tokens that are usually tokens that represent um, a stake in a company or an organization or a platform that it's being created. So we also have that kind of tokens that can be created on the blockchain. And finally, we have the asset tokens that represent ownership of a particular digital item or physical item, as the case may be. Now, asset tokens are, certain kind of unique tokens that I will also talk about later in the future as we go through the course of this um, tutorial. So basically, these are what tokens are in regards to blockchain. And today's video, we're going to see how to create these tokens. We're going to first of all see how the structure of these tokens are and how to create them on the blockchain and how to also share it with our friends and families and loved ones. So stay back with me while I take you through this tutorial on how to write and publish Ethereum tokens in Solidity language. So you will first of all need to be a bit conversant with any programming language. Solidity is quite easy to learn, especially if you're coming from the C-like programming languages. When I say C-like programming languages, I mean languages like C Sharp, Java, uh, JavaScript, C++, and the rest. So once you're familiar with those kind of programming languages, then Solidity, it's very easy to learn. Today we're going to learn Solidity by creating Ethereum tokens on the Ethereum blockchain. So once again, my name is Ayuba Ojonobomazu, and sit back and enjoy the ride with me. Thank you. So this. Hi, welcome to session 2 on this video series on how to write and publish Ethereum tokens using Solidity. My name is Ayuba Ojonobomazu. Now in session 2 here, we are going to set up our development environment and the necessary tools that are required to be able to write and publish our Ethereum tokens we talked about in session 1 in this project. So, and the necessary tools we're going to need are these. We're going to need Metamask, we're going to need Remix, and we're going to need Truffle. So I'm going to explain what all these tools are. First of all, I'll start with Metamask, and the best way you can get to learn about Metamask is to go to the Metamask website. So let's go to metamask.io, and then let's see what Metamask is all about. Now, Metamask is a crypto wallet and a gateway to blockchain applications. So MetaMask is your door, or rather your gateway to blockchain applications. And blockchain applications, we call them the apps, decentralized applications. So this is the MetaMask website. Make sure it's usually HTTPS, so that you're on the correct website. So you can see buy, store, send, and swap tokens. So basically, MetaMask is a wallet, but it enables you to do much more than just being a wallet. Like, it's like a gateway to decentralized applications. Applications you're going to create on the blockchains, the Ethereum blockchain, can actually connect via MetaMask. You can actually use MetaMask to connect to your applications and send value, store value, and do all other stuff that your applications is required. So you can see on your data, MetaMask generate password and keys on your device, so only you have access to your accounts and data. You always choose what to share and what to keep private. Now, in installation of the MetaMask, I'm going to show you why all this is very important. So once you open MetaMask, you can scroll down and read more about it. It's a beautiful project, and it's one of those projects that's contributed, immensely to the Ethereum blockchain. So MetaMask works on Chrome browser, Firefox, and Brave. So I don't know for now if they have included in Internet Explorer, but I still doubt at the time of this recording. So we can, well, anyway, you can check support. You can see what this is all about. Now, to show you how installation of MetaMask is actually very easy, but I'm going to uninstall mine because I have mine here. I'm going to remove this, and then we're going to install this together. So I'm going to remove this. So now I don't have MetaMask on my system, and I'm using Windows operating system. So let me click download now to be able to use MetaMask. So you can see you can use MetaMask on iOS, Android, and Chrome. And so these are the supported browser. Okay, supported on Microsoft Edge now. All right, this is a beautiful thing. So let's click install MetaMask for Chrome since I'm using Chrome browser. So while we're installing MetaMask, one of the reasons is because we will need MetaMask to be able to interact with the tokens we are going to design. We can actually write those tokens. We can actually um, interact with those tokens without MetaMask actually, but it's also good for you to learn how to interact also with MetaMask. So now, see, scroll down to read more about it and everything that is needed, especially your private key. It's very important to save it, your seed phrase. So let me just go right ahead and click add to Chrome. So I'm okay with this, so I just click add extension. And the MetaMask extension is downloading here. As soon as it's done, we're going to have this all set up. So you can see it says here an Ethereum wallet in your browser. So that's one of the features. That's one of the features that made MetaMask to be so great. And Metamask is an extension for accessing Ethereum-enabled distributed application, or the apps, just like I said. The extension injects Ethereum Web3 API into every website JavaScript context so that the apps can read from the blockchain. Metamask also lets users to create and manage their own identities via private keys, local client wallets, and hardware wallet like Trezor. Okay, so let's just wait for this to be installed. And then, like I told you, we can actually do this with our Metamask, but the idea of knowing how to install Metamask, store your cryptocurrency securely, and use it for future development, it's also very important in becoming a blockchain developer, especially an Ethereum blockchain developer. This usually doesn't take this time. It's long. Probably my internet connection is not very strong, but I think we're almost done since it's adding to Chrome right now. Okay, let's just wait a little. And recently, Metamask has improved a whole lot of security features that you can okay, so Metamask has been added to Chrome. So we have this. I can go right ahead to remove this for now. Okay, here are my extensions. So I click to open Metamask. Okay, so here is the process to get started. You can see this little, there should be a fox, right? You see this little fox following my cursor wherever it went. So now I click get started. Now there are two ways you can actually get started to Metamask. If you have an existing Ethereum wallet, you can actually import the wallet here, especially if you have the recovery phrase rather, or you set up a new wallet. In our own case, let's first set up a new wallet by clicking create a wallet. So you can see here are some warning and some tips that will help us to get started following security best practices. Metamask will always allow you to opt out of your settings, send anonymized click and pay through events. And Metamask will never collect keys, addresses, transaction balances, hashes, or any personal information. Metamask will never collect your full IP address and will never sell data for profits. Well, that's what they say. So we agree to this. Now you are going to set up your password. So just put any password, minimum of 8 characters. I'm just going to put something that I'm okay with. Confirm the password. And I've agreed to the terms of use. So I click create. Okay, here's a short video on how you get started It's basically about securing your wallet, about security phrases and all that. So you can watch that video if you want to, but you can just click next. So well, this is a test wallet I'm gonna use. So I can so you can see it says something here. Secret phrase makes it easy to back up and restore your account, and never disclose your secret discovery phrase. Anyone with phrase can take your money forever. So now if you click here now, you can see your secret words. Now here is mine here, and then I can write this down somewhere, because Metamask will also ask me to verify this. So let me just write this down somewhere, piece of paper. So you should also write yours too. Okay, so I click next. Now you see I have to select each phrase in order to make sure it's correct. So the first one is this, then this, then this, then this, then this, 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 this. So I can confirm this. And all done. So I'm able to have this. Now I'm gonna have an Ethereum wallet now. You can see with 0 Ethereum in it, and here is my wallet address, and here I can change the network. I have Ethereum mainnet, Ropsten, Coven. These are the different Ethereum networks that we can actually use for our development purposes. So the mainnet is where your real ether resides. The others are testnets, where you have false ethers that are not valuable. So once you click on this, you can copy your Ethereum address. Now, of course, there are other settings. Again, you can look at from here. You can check the account details here, the connected sites. That's connected site here means the apps that I'm going to connect to. Okay, so that's that about Metamask. Let's quickly go to Remix IDE. Now, installation of Remix IDE is just very easy. You just go to remix.ethereum.org, and that's all you need. So it's an online tool that we are going to use for writing and deploying our smart contracts faster, easier, and in a more secured manner. So that's that about Remix. So it's just going to open now, and then we can see how it looks like. Depending on your internet connection, yours might comes up a bit faster than mine. Okay, like it says here, make sure you always use HTTPS connections, secured connections to any sites you're using. Okay, so here's the Remix interface. I'm going to show you later once we start writing our token smart contracts along the course. So here's it. Then of course, once you click on this folder, you can get to see the smart contracts you've written. I've written some smart contracts before, so they are here. And then We also have some tabs here, Solidity compiler. I'm going to show you this later. We'll have where you can deploy smart contracts and all that. And these are plugins you can add. So if you don't have these, you can click on Solidity to make sure you have the Solidity compiler plugin, and also make sure you have the deploy and run transaction plugin, so you can add them from here. You can click more, just play around it, see different kinds of plugins here that you might want to try out later. But for our own simple case here, what we just need is the compiler, and then the deploy and run tab, and this tab, and we can have a list of our folders. So that's just that about Remix. It's very easy to use, and it's just an online tool. You don't need to install anything, just go to your browser, and then I'm going to show you how you can connect this to Metamask later. Then the last but not the least is Truffle, another tool that we can use to write our smart contract. Now we can see how to install Truffle probably by going to the Truffle website, or you just open your command prompt. I'm using Windows, so you can see I've been doing this. Just close this. So kill that process. So if I go to my command prompt, and if I go to Truffle website, just to show you, depending on the operating system you're using, so you go to trufflesuits.com. Did I click on settings? No. So here is about everything about Truffle. You can get to read about it, and you can also quickly go to the tutorials or guides. You see different tutorials on how to create some decentralized applications like this pet shop. You can read about it, and Truffle will make your development life very easy. And then you can also see guides. You can play around it, and then you can also see docs. You can click on Truffle because you have Truffle, Ganache, and this. Now you can quickly go to installation. Anyway, this is Truffle. This is what it's all about. Truffle, world-class development environment, just like Remix, but here you have to do some installation, testing framework, and asset pipeline for blockchain using the Ethereum virtual machine, aiming to make life as a developer easier. With Truffle, you can build a smart contract compilation, linking deployment, and binary management, automate contract testing for app development, and all other amazing stuffs here. And of course, the installation is easy. Just click on installation. Check your requirements, whether you're using Windows, Linux, or Mac, and then basically you just npm install Truffle. So that's how easy Truffle is. So you just put your command prompt and you type this, and Truffle will install on your operating system. So okay, so that's that about session 2 of this video series, how to write and publish Ethereum tokens. So stay on to this video while we move into the next session. Thank you. Hi, welcome to session 3 on this video series on how to write and publish Ethereum tokens in Solidity. My name is Ayuba Ojonuwa Muazu, and in this session 3 here we're going to discuss the structure of an ERC20 token, which is a special kind of token that we talked about in session 1 when we describe what is a token and different use cases of tokens. Now in session 3 here, we are going to discuss this special kind of token called ERC20 token, which is like I said, is an Ethereum class of token that's it's currently being used by different companies, different organizations, and all that. So yeah, first of all, what you need to understand is that ERC20 token, it's actually a fungible token. And then fungibility, what it means is the right to exchange a product or assets with other individual products or assets of the same kind. So it simplifies the process of exchange and trade, and fungibility actually implies equal value among assets. So for example, your $100 bill is has the same value with another $100 bill that someone else uh, is holding. So there are different lists and examples of fungible goods that I can call for you, like gold and other precious metals, um, money, like a fiat currency, uh, oil, bonds. These are all example of fungible goods because one unit of weight is the same everywhere. Now, after this session, in the next one of the sessions, we are going to talk about non-fungible tokens. So in this session here, we're talking about fungible token, and we want to see the structure of this ERC20 fungible token, and later on we are going to see how we will program this and publish it using Solidity. So first of all, let me still take you back to what a token is. In session 1, we said a token is a virtual currency or a denomination of a cryptocurrency, and it represents a tradable asset or utility. Then if you notice here, we say tokens can reside on blockchains, token that reside on blockchain, which means tokens can reside on blockchains. So here we can, since tokens can reside on blockchain, we can actually write smart contracts to prove the ownership of a token. So basically, you can also say a token is a smart contract that records and manages the ownership of digital currency. And we need to find a way to represent the balance of tokens that is being owned by different categories or different categories of people or entities. You need to find the balance of tokens that is being owned by different entities. So that's what we are going to discuss on the structure of this ERC20 token here. Now, if you look at this repository in the middle here, I said something token ownership and approval. So think of this as a data store. Think of it as a data store where the tokens are stored, and then what the characteristics or the structure of a token or the structure of money itself, that you can also digital money itself, is this. If we have this repository here, we need to find a way of getting the balance of everyone that owns this token. So if we have 10 people owning this particular token, we need to know the balance in each and everyone's address or wallet. And if the balance in your wallet is 0, it means you don't own that token. So one of the characteristics of an ERC20 token is for us to know the balance of each token holders. We need to know the balance that's of each token holder. And then secondly, we also need to be able to transfer. Each token holder should be able to transfer token from one token holder to another. So we need a function, or we need these characteristics of transfer. Now this transfer here, we have two kinds of transfer here. We need to have a way of transferring from the repository to a token holder, and we'll also need to have a way of transferring from one token holder to another. So we need to have the transfers. Then we can also have this function of approving someone to spend tokens on our behalf. Since this is a digital representation, since this is a digital token, we can actually assign another entity to, or rather approve another entity to spend our token on behalf of us. So it's also part of transfer. And then we need to also, when we are approving someone or an entity to spend that token on our behalf, we need to know how much of that token that person is allowed to spend. So we also need this allowance function to be able to know how much that entity is allowed to spend. Now, here is a more detailed structure of the smart contracts that we are going to write, a token smart contract that we are going to write. If you see here, we have reference data on which, first of all, we have the name. So we need to know the name of the token. We need to know the symbol of the token, just like we have our US dollar and the symbol is USD. And then we need to know the decimal points to which that token is represented. So these are all reference data that we need. And then we also need to know the balance of the token. We need to know the total supply of the token in our repository. So for example, if the contract issued out 10,000 tokens, for example, we need to know the total supply of that token in circulation. And for each address, or for each wallet, we need to know the balance that wallet has. So if someone owns our token, we need to know the balance of the token owned by that person. And then here, of course, I discussed this, we also need to be able to transfer tokens to the repository or from one entity to another. Then, of course, we have this delegation. We can approve someone to transfer token on our behalf or to spend token on our behalf, and we need to know how much we are approving for that person, how much we are allowing that person to spend on our behalf. So you can see we have static data, static contract data, and we have token ownership and approvals, of course, which is this. Then we can have these events on the blockchain whenever a transfer happens or whenever an approval to spend token on our behalf happens. So we can have these events. So this is a detailed structure of how an ERC20 token should function. So in the next video, we are going to write the smart contracts leveraging on an already existing library called OpenZeppelin. So we're going to do that on Remix, and then we're going to see how we will deploy it and use it later, and also share it with our friends. So thank you for watching. Hi, welcome to session 4 on this video series on how to write and publish Ethereum tokens in Solidity. My name is Ayuba Ojenogwama. Now in session 4 here, we are going to construct the ERC20 token contract on the Remix IDE. If you remember in the last section, we discussed the detail of how an ERC20 token should look like. And when we talked about the reference data, the attributes that the ERC20 smart contract should look like. And then we also talked about the balances, like getting the total supply, the balance of an address, or the balance of a wallet, and then we should be able to transfer and transfer from, and then we should be able to also delegate all the wallets to spend tokens on our behalf by giving them an allowance approval. And then of course we also have these events that should be emitted whenever these transactions happen, like the transaction of transferring funds from one account to another, and when an approval is being made. So in this session here, we are going to write the token smart contract. And better still, we already have a library that has been tested, battle tested to, carry out all these functions for us. And that is the Open Zeppelin library. So I'm going to take you to Open Zeppelin library. Go to github.com/Open Zeppelin, and we have these libraries, a whole lot of libraries that's been written here, and we're going to focus on Open Zeppelin contracts. Now, to know more about Open Zeppelin, you can actually Google them. You can just say Open Zeppelin, okay, and I think it's openzeppelin.com. I don't know, can't remember. So you can actually Google Open Zeppelin, and you are going to see what they are up to. So if you go to openzeppelin.com, it takes you to the Open Zeppelin website, and you get to see what they do. Now, Open Zeppelin provides security products to build, automate, and operate decentralized applications. We also protect leading organizations by performing security audits on their system and products. So you can see a whole lot of big names are actually using Open Zeppelin, like virtually any big name you think of in the crypto world. So now we're on the GitHub page of Open Zeppelin, and you open this Open Zeppelin contracts. You go to contracts now, because we are focusing on ERC20. So we go to tokens. You can see they have a whole lot of contracts that have been written here. So let's go to token, and then let's go to ERC20 token, and then you can read about it here. Read everything about it here, because the ERC20 token has different extensions. Like we have the bondable, where you can destroy your own tokens. We have the cap to enforcement of a cap to total supply when minting tokens. We have the possible, the snapshot, the permits, the flash mint, the votes, support for voting and delegation, and a whole lot of ERC extensions are here. Now we are just going to pick a very simple one. Let's just pick this ERC20.sol, and then we look at it. So as you can see, this is an ERC20 Solidity file, smart contract, and we're declaring the smart contract here. You can read all this. We're declaring the smart contract here, and we are inheriting from is keyword means we're inheriting. So we're inheriting from context, ERC20 metadata. So, and if you remember, we talked about okay, let me show you from here. We talked about the reference data, name, symbol, decimal, and then balances. We talked about total supply and balance off. And it's the same thing here. So you can see we're mapping each address to balances, and we're mapping each address to the allowances that it can spend. And then of course we have total supply, name, symbol, and decimal. Do we have the decimal here? Okay, we can add that if we want to. So you can see we have name, symbol. This is the constructor when we are initializing the smart contract. So this is the constructor. We give our token a name and a symbol, and then we have a function that returns the name. We also have a function that returns a symbol, and then we have a function that returns the decimal. Returns actually, so it's to 18 decimal points. And then we have a function that returns total supply, and we have a function that returns the balance of an account. So we want to get the balance of an account, we have this function here. Then we have a function that transfers from transfer tokens to the recipient and the amount you're transferring. So So we call this transfer method here internally, I believe. So, and then the recipient address and the amount you're transferring to that recipient. And then we also have the allowance function that this is the owner, the address of the owner of the token, and the address of the spender that we're delegating to spend token on our behalf. Then we also have the approve cause. We have to approve an address and the amount we are approving for that account to be able to spend, just like I explained. Then we have transfer from. Now here we're transferring from an account, that's the sender account, to the recipient account and the amount we're transferring. And then we also have some check and balances that we need to do here. Like we need to check that the amount, that the current allowance is not greater than the amount. So we need to check that. So these are battle-tested functions or library that has been written by OpenZeppelin. And we can also increase the allowance. This is an extension actually. We can also increase the allowance of the spender to be able to spend token on our behalf. Since we can increase the allowance, it means we should also be able to decrease the number of tokens an address should be able to spend on our behalf. Then this is an internal function that we called for the transfer. We'll have some check and balances here. Like for example, we cannot transfer from 0 address and we cannot transfer to 0 address. And we'll make sure that the sender balance is greater than the amount that he is sending. So, and all that's, I don't know why they use this. We're supposed to use safe maths here actually. And then of course, we also have this extension here for the smart contract, which is we can mint tokens, into an address. But we're not really going to talk about these for now because it's not what we focused on. So if we can mint tokens, it means we can also burn tokens. So we can mint into the repository, we can add more tokens to the supply, and we can decrease token from the supply, from the repository. That's what that means. And then of course we have the internal function for approving amounts that someone can spend on our behalf. And then before token transfer, we can also check this. So these are internal checks. Now OpenZeppelin has done this for us. So how are we going to use this now? Very simple. You go to your remix, ttm.org, go to remix, and let's create a new contract. Let's create a new file. I usually like to put these in a folder. So let me just create a folder and say let me say ERC20 sample, right? So I'm creating this folder in another folder. I'm supposed to do that. So let me delete this folder. So don't worry, whenever you close your browser, your smart contracts don't get lost. They're saved somewhere. Yes, sure, I want to delete this. I hope I didn't delete. Oh, I deleted everything. Oh, that's bad. Oh, I actually deleted everything. I don't have any local file on my system. Okay, let me create this default workspace. Okay, well, actually lost that. Anyway, I have sample of that somewhere. So let me create a folder. So yours probably will be like this. So let me name this ERC20 that's a folder in my contract, and then I'm creating. You can right click and then create a new file, and then you can say ERC20 token.sol. So every Solidity file should have .sol extension. Now we have this. Let me just open one of the smart contracts so you get to see, so that I can explain things from here. Now the first thing is your smart contract should start with these keywords here, Pragma Solidity, where you define the version of your compiler. So for easy use, we can just pick this and then we can paste it here, so you can write this yourself. So now, and then if you look at here, we also, the keyword here is contract, and then the name of your contract before you can write anything you want to write. But in our own case now, we want to import this contract from Open Zeppelin. So what are we going to do? It's very easy. So we just to show you all the contracts. Good. So we import this URL. So you can copy the URL. Okay, sorry. We want to import ERC20, this, and then this. So here's what we're going to do. I think I can open this in another tab. And then we want to import this. So we pick this ERC20, which is an interface that defines all the functions that I just mentioned about. You can see it here: total, balance of, transfer, allowance, approve, transfer from, and transfer. So basically these are what I just explained. So we can just pick that, just pick this URL. So we can import that. And secondly, we will also want to import this extension ERC20 metadata. So we can search for that too. That should be on the token. ERC20 extensions. And then ERC20 metadata. So we can pick the URL of that. This is just an extension of the name, symbol, and decimals that we have. So we copy that, and then we also run another import statement. So we say import then thirdly, we also want to import this URL here, utils context.sol. So we can take that from here. That should be on the tokens, I believe. Utils, okay, not utils on the token. So we go back to contracts, and we search for utils here. we search for context. Context.sol. So we copy that, and then we also run another import statement here. So we say import. So good. So we're able to import these libraries from OpenZeppelin. And the next easiest thing to do now is to just copy the whole lines of code starting from line 10 straight down to the last here. And then we paste that in our Remix IDE. So if everything goes fine, this will show a green mark here, or warning if we have encountered an error, but if we don't, so everything goes fine. So this contract is compiled successfully, just like how I explained to you, with all the functions that we have here. So let me pause this video. In the next video, we're going to publish these contracts and then interact with it using Metamask. So thank you for watching. Hi, welcome to session 5 on this video series on how to write and publish Ethereum tokens in Solidity. My name is Ayuba Ojonuguamu. Now in this session here, we're going to publish the ERC20 token we developed in session 4. We're going to publish that on Remix using Metamask. So to do that, it's very easy. You first of all need to have Faucet Ether on your Metamask wallets, so you can be able to use that to pay for gas. So head on to Metamask and click to copy your address. So click here to copy your wallet address. Then you go to faucet.ropsten.be and then you put your address here and then you click send me Ether. So you just wait for some highest maybe 1 minute and then you get to see your Ether deposited to you. So I have 0.3 Ether that has been deposited to me, and then you can change the network. If you're on mainnet, you can change the network to Ropsten so you can see your Ether deposited to you. And once you have this, the rest is we go to the Remix IDE where we were able to successfully compile our ERC20 token sample smart contract. So which of course this is the contract ERC20. So you can actually change this to ERC20 sample if you want to. Now this contract is compiled successfully, so you can see we have this green button here. Now let's go to the deploy tab. Now here we have environments. This is where we select the environment we want to use for deployment. So let me go to injected Web3. Now you can see this pops up Metamask. So this can be able to connect to my Metamask. If you remember, we said Metamask is your gateway to decentralized applications. So, and that's exactly what we are doing now. So we're connecting Metamask to this app we just created. So it's telling me to connect Metamask to this account. So I just go ahead and click next, and then I click connect. So this is automatically connected, and you can see my address is being displayed here with the total amount of Ether that I have. Now, to deploy the smart contract here, once you come down here, of course, you select the ERC20 token.sol, which is the smart contract we have, and then under this deploy, in this deploy button, you can click on this arrow. You can see it's asking us for name of the token and the symbol of the token. And if you recall, our token decimal is to 18 decimal point. So let me just show you these via codes, which is this. So here's a constructor. We're getting the name of the token and the symbol. So let's say I call this my token, and then I call this my TKN as the name. That's the symbol of the token. So I go right ahead and click transact. So this will also pop up Metamask. And then you can see contract deployment. So I'm just going to pay for gas, and I just click on this to pay for gas. And mind you, we're deploying these on the Ropsten network. So like I said, make sure your Metamask is on the Ropsten network. So you can watch how everything is being done here. Let's wait for a little while. Just wait. We can actually watch this transaction, and to do that, it's easy. Okay. So transaction confirmed. So I can view this on Etherscan. Once I click on that notification, so this will open it on Etherscan, ropsten.etherscan.io, the transaction ID. So let's get to see the detail of the transaction. You can also see this too by okay, you have to pin Metamask. Yeah. So once you pin Metamask, you can also view transaction. Okay, so you can see our transaction is and here's our contract address. Our transaction is successful, and then it's from this account. Here's our contract address. You can scroll down to see more details about the transaction, like the gas fee we paid, the gas price, the gas limits used by the transaction, and all that. So we get to see this information. So the most important thing here is the transaction hash and the transaction address. So now that we're able to do this, if we scroll down here on your Remix ID, scroll down, you can see this is the contract address. So you click on this little arrow down, and then all the functions of this smart contract are being displayed. Now, this smart contract that we derive from OpenZeppelin, we didn't have a total supply when deploying this smart contract. We didn't give a total supply. So if you click a total supply now, you're probably going to have 0. So that means there is no token in circulation. We just created an empty token that is not in circulation. But then I think we have a main function. Let me scroll down and see. Okay, this main function is internal. Just want to see. Okay, this means function and bond function are internal, so that's why we are not being able to see them. But these we can easily modify this by by doing this. So just want to modify the smart contract a little, so we have a total supply. So you can do this with me. Total supply. I want to have an initial total supply. And then okay, so the address, these two sorry, balances of messages sent, or rather balances. So what I just did here is to update the balance of the address that is deploying this smart contract to get the total supply. So that's just what I just did here. So we can redeploy the smart contract again. So I can clean this up, and then you can see it's compiled successfully. So in redeploying now, you can see we have total supply. So let's say the contract is my token, and then my TKN, and then we said this is to 18 decimal places, right? So we are given this amount of tokens. We want to give 100 tokens, so we write 100, then with leading 18 zeros. So we'll click on transact. Okay, so click on confirm. We wait for that. So this contract is confirmed, and then if we scroll down, we get to see the contract details here. So now if I click on total supply, okay, oh well, I didn't update I didn't update the final total supply. Anyway, what I did here was just to get the balance of I think you need to do this as an assignment then. But if I pick this address of my account, check the balance of that address. You can see we give all the tokens to that account, the account that deployed that. So as an assignment, let me just explain what you need to do. Now, we give these all the tokens to the account that deployed the smart contracts, but then we need to update our total supply when doing that. So what you just need to do here is you can just update your total supply. You just add this to if you want to get a total supply, you just so you can just do this as an assignment. Anyway, you can add this to your total supply just like I did, but I don't really need to deploy this again. And then by doing this, anytime you transfer tokens out, you also have to reduce your total supply. So we can add this as a plus actually. So we add this to our total supply. And then anytime we make a transfer, this is just an assignment for you. You can check this out, and you can also reach out to me if you run into any problem. So anytime you make a transfer, you can reduce your total supply here. So anytime you make a transfer, you can see a transfer has been made here, and then the balance of the recipient has been added, and then you can reduce your total supply from here. Anyway, we're able to deploy our smart contract token, and then if we click on the name, we get to see my token symbol, we get to see the symbol, and then we get to see the decimal point. It's 18. So you can transfer from one address to another. You can try this out by putting the recipient's address and then transferring from the address to the recipient, owner's address to the recipient's address. So this is how we deploy token on the Ethereum network using Remix and Metamask. Alright, stay with me until the next video where we will continue with non-fungible tokens. Thank you for watching. Hi, welcome to session 6 on this video series on how to write and publish Ethereum tokens in Solidity. My name is Ayuba Ojanugwa Moazu. And here we're going to discuss the structure of an ERC721 token. It's good for you to know that an ERC721 is actually called an NFT token, so a non-fungible token actually. So the ERC20 token we discussed was a fungible token, and now we are discussing non-fungible token. And the difference between a fungible token and non-fungible token, it's the uniqueness of a non-fungible token. Just consider a non-fungible token like a piece of an art, where each piece of an art is completely different from another piece of an art. So if we decide to tokenize a piece of an art, decide to tokenize it and make it digital, then we'll have to find a way to represent the uniqueness of that piece of an art. And one of the ways we can do that using ERC721 token is by the feature of token ID, by using token ID as one of the features. So for each NFT tokens, we identify it with a token ID. So basically that token ID is the major difference that we have actually between ERC20 tokens and ERC721 tokens. So that token ID defines the uniqueness of each token, and if we're transferring NFTs from one person to another or from one ownership to another, that token ID gets transferred to the other person. So if you look at this contract here, the structure of this contract, you can see that Just like the ERC20 token, we have name, symbol, total supply, balance of, and then we have the owner of that token. We have approve, we can approve another address to spend that token on our behalf, and then we have take ownership, transfer, token owner, token of owner by index, and token metadata or the relationship or the characteristics of the token. And then we have these two events, transfer and approve, just like the ERC20 token. So like I said, the token ID basically differentiates each token, the uniqueness of each token when we're representing an NFT. So in the next session, we're going to see how we can write this ERC721 token using Truffle, and how we can write it and deploy it using Truffle, which I introduced you to in the beginning of this session. So just sit back, relax, and then let's move on to the next video. Thank you. Hi, welcome to session 7 on this video series on how to write and publish Ethereum tokens in Solidity. My name is Ayuba Jonagwamo Azu. In session 7 here, we are going to construct our ERC721 token contract. If you remember, we constructed the ERC20 token contract using the Remix IDE and Metamask. Now, in this session here, we're going to look at a completely different development environment called Truffle, and we are going to see how we will construct these smart contracts and deploy them using Truffle in our local environment. So we're going to leverage on the OpenZipperLane smart contracts that we have, and we are going to see how we can leverage on that. So if you remember, I took you to OpenZipperLane, so let me try and open that. Okay, OpenZipperLane. I can just open the contracts. I guess my internet's a bit. Okay, all right, then let me refresh this. So okay, here's ERC20. Let's look at ERC721. Good. So we have different tokens here. We have ERC1155, ERC721, ERC777. So this is the contract we are going to work with, and basically we're going to work with this under presets here. Preset minter pauser auto ID SOL. So this will enable us to be able to mint tokens and bond tokens accordingly. So I'm just going to show you how we can deploy this using Truffle, since that's what this video is basically focusing on. So to start that, you go to your command prompt. I'm running this from Windows operating system, and it's basically the same thing if you're using Ubuntu or any other operating system of your choice. So I'm gonna make a directory. I call it my NFT2 because I've created one before, so I cd into my NFT2, and then now I'm going to install the OpenZipperLane, which has the implementation, of course, of the ERC721. So just going to npm install save dev at OpenZipperLane /const contracts. So I'm just going to install all the contracts of Zipline. So I'm just going to wait a little while this gets installed. So just wait a little while. Okay, so just wait a little while. This operation will install all the contracts that we need. Good, I think this is done, and you can actually see this if you go to my NFT2. It should be on the PC. So mine is saved here. So good. So here's my NFT2, and then of course here's open Zipline. Here are all the contract codes that has already even been built, so you can see. So we have all this. So let's go back here. Now the next thing we need to do is to install Truffle. I introduced you to Truffle and what it means. So we're just gonna do that now. So just say npm install Truffle. So wait for that again. So this will also take a little while for this operation to complete. So let's wait a bit. So this will install Truffle and all the necessary things we need to get our smart contracts running in both our local environment and test and main networks. So we'll just wait a little while for this operation to complete. So we just wait a little. This is quite a long operation. This operation is quite a wait. Just have to be patient enough. So this is installing all the necessary tools we need just to show you how this is done step by step. So like I said, we just wait a little while. So once you have the truffle installed, it makes your development um, time much more easier. Let's just wait. Wow, this is taking quite some time. Oh, we'll have to complete this operation before we move to the next one, basically. So let's just wait for 3 more minutes and see. Okay. Let's just wait a little while. Probably maybe I will just have to like pause this video and we continue in the next session. I guess that's what I'm going to do. Just pause this video and then continue in the next session. By then this would have installed completely. So okay, so we have Truffle installed completely. This actually took some time, so I have to pause the video. So the next thing now is next thing we need to do now is to set up the Solidity project using the Truffle init initialize. So I'm going to do that now. So I'll just say npx Truffle initialize. Okay, good. So this has started it, and you can see once you have this information in a successful suite, it means that everything it's going fine. So the next thing is I'll make a directory, build directory. Oh, I think I can just do this directory build, cd into build, make a directory contracts, and then now we need to copy once we go to we need to copy what we have here. So I think I can just do that manually. We need to copy Open Zeppelin contracts, build contracts here. We need to just copy everything. And then we paste it here in this build and contract directories we just created. So paste everything here. You can actually do this on the command prompt too, but I just want to show you what we are doing. So now the next thing is I need to create a file in the migration folder, or in this folder here. I need to create a file in the migration folder, which is this file here. Let me open it so that you get to see. Actually saved it before. So because we are deploying this ERC presets Minter Pulsar Auto, so just create this file here. Just look at it. You can pause the video and just look at the file here. So I'm gonna save this file as 2_deploy.js. So I can change this to all. Yes, I'm gonna replace it because I've done this before. So now here is the file. So I'm gonna copy this and then I paste this in the migrations folder. Good. So if I go back here, so I'm gonna do this. To deploy the contracts into the local blockchain. Good. So you can see accounts are generated and with the corresponding private key and mnemonic. So I can just say migrate. So this is compiling my contracts. Okay, so we're doing this now.
So good, we're able to now we can use our contracts. What we're gonna do now is we say the NFT weights ERC721 preset mint auto ID deployed. ID, am I getting something wrong? Yeah, I guess I'm not getting the correct name here. ERC721 preset mint pulse auto ID. Oh, okay, yeah, that's what we need to do. So we'll just say NFT weight ERC721 presets mint pulse auto ID. So good, so we have that now, and then now we can check the name of our token and all other information. Okay, so we deployed it as my NFT, and then of course we can check the symbol. We can say NFT dot symbol, and which is NFT. So here is how we can deploy our tokens, Solidity. How can deploy a token using Truffle and interacting with the token. So I hope you learned a lot from this tutorial, and thank you for watching. Bye.